Vectors and two-dimensional motion. In section 3.1, our learning objectives are to apply the definitions of scalar and vector to categorize different physical quantities, and 2, to use the geometric interpretation of vector addition, subtraction, and multiplication to find the resultant vectors of those operations. Now, we've discussed this before, that a vector has both a magnitude and either a direction or a sign, and a scalar has a magnitude only. And the magnitude is the size of something. Something they don't bring up in the book, but I think is notable, is that the vectors generally have a direction denoted in terms of distance. So whether it's displacement, velocity, acceleration, momentum, or force, all of those are going to have meters in them or some other form of distance, unit of distance. There are also quantities such as directional pressure and linear density, which end up having a unit of distance on the bottom, and they work a little bit differently in the math. But I'm not going to get into that right now. We're going to be focused on this type of vectors, the ones that have meters on the top. Equality of two vectors. Two vectors A and B are equal if they have the same magnitude and the same direction. Notice figure 3.2. These four vectors are equal because they have the same magnitude and the same direction. Having the same origin, or they have the location of the tail is different in all four cases, but they still say the vectors are the same, are equal. The tail of the vector is the back end, and the point of the vector is the front end. When you add vectors, make sure to get them in the same units first, and then you can add them either geometrically or algebraically. Let's look at figure 3.3. Here we have vector A plus B adding up to the result A plus B. Here we have B plus A adding up to the result B plus A. Here we have A plus B plus C plus D adding up to the result A plus B plus C plus D. Notice all of these things have a little vector sign above them, because if we did this with their magnitudes, it wouldn't come out right. So the term is called commutativity when I can go A plus B equals S, or I can go B plus A equals S. If I've got B plus A plus C equals S, I should be able to add these up in any order and still get S. So then I try C plus, ooh, it didn't like me moving that down there. Oh well. Here we go. I moved the origin. C plus B plus A, and I should still get, oh, I didn't get this on the point. Gotta go to the point, C plus B plus A, and it still gets S. So I can add those together in any order, and that's called the commutative property. Commutative property includes just the commutative property of arithmetical addition is that A plus B equals B plus A. Commutative property of multiplication is A times B equals B times A. And something that isn't commutative is division. A divided by B is not equal to B divided by A. Or subtraction, A minus B is not equal to B minus A. Whoops. But you can convert these into a commutative thing by saying A times 1 over B equals 1 over B times A. Same thing with 1A plus negative B equals negative B plus A. So that by converting that into 1 over B and negative B, you can turn the division and subtraction, which aren't commutative, into a multiplication and an addition, which are commutative. So this term here, absolute value of vector A, is the magnitude of the vector. And you can see as I move it along here, as I move the tip to the left and right, it goes bigger and smaller. And also, if I go this way, it doesn't turn negative, it still gets bigger. However, the angle is changed from 0 degrees to 180 degrees. So when I flip it around, it goes up by 180 degrees. The quantities a sub x and a sub y represent the x and y components of A. So as I move it back and forth, the x component gets smaller, but the y component stays 0. If I move it up, the y component gets bigger, and down, the y component gets smaller. Okay, now watch the angle as I bring it around in a circle. You can watch the angle go up to about 90 degrees up here when I get it on the y-axis, and then to 180 degrees as I go over here and get it to the negative x-axis. And it pops around from 180 to negative 180 as soon as I drop below the negative x-axis. So it's measuring a negative angle between here and here. And so that is where that angle comes from. Quick Quiz 3.1 tells us the magnitudes of two vectors A and B are 12 units and 8 units, respectively. What are the largest and smallest possible values for the resultant vector r equals A plus B? So here are our two vectors. A is 12 and B is 8 in length. And as I move this guy around, it's hard to keep him exactly at 8, but I can get it over here so that B is equal to 8 right there. And you see that the sum is 20. And then I move it around here, so B is 8. Oops, 7, 8. And the sum is 12 minus 8 is 4. Anywhere in between, you're going to come up with a sum somewhere between 4 and 20.